Hey guys, Mr. Milton here. Today we're looking at areas of regular polygons. Number one. At the end of this video, you should be able to find the area of a regular polygon using special right triangles. Okay, in the next couple lessons, we'll find the areas of regular polygons, but today we'll focus on the ones where we use special right triangles in our process. Okay, the figure above is a regular hexagon because it has 6 sides. Since it is a regular polygon, remember that regular means that all of its sides and angles are congruent. Okay, so regular does not mean normal or what you're used to. It just means that all sides and all angles are congruent. The middle of the polygon is called the center. It's here. And each of the blue dotted lines represents a radius, which is the distance from the center of the polygon to a vertex. The red dotted line is called the apothem. This is a segment from the center that is perpendicular to a side. Perpendicular. Okay, make sure you're familiar with those terms. Notice what one apothem and one radius form. A right triangle. All right. So, in the figure above, as we look at naming some of these things, angle 7 is a central angle. It is formed by 2 radii. How many central angles are there in a hexagon? Well, a hexagon has 6 sides, so it has 6 central angles. How about an octagon? It has 8 sides, 8 central angles. If all the central angles come together at a point, the center, all of those angles add up to 360 degrees. Okay, think about it. It's a circle. Okay. So in a hexagon, what is the measure of each central angle? Well, we can do that and say hexagon has 6 sides, so 360 divided by 6 gives us 60 degrees. How about in an octagon? 360 divided by 8, I got to do that in the calculator, 45. The apothem cuts each central angle in half. Okay, so as we look at this, what's the measure of angle 8? Well, the whole central angle, like we said, was 60, cut in half, must be 30. Okay. Let's look at our first example here. It says, find the area of the regular hexagon. Leave your answer in simplest radical form. So, without knowing anything else about what we're talking about today, we have 1, 2, 3, 4, 5, 6 triangles here that are all going to be the same because it's a regular hexagon. If we're just asked to find the area of this hexagon, then we might say, hey, let's find the area of one triangle and multiply it by 6. Okay, so let's do that. For the area of a triangle, we need the base and its height, perpendicular height, which, nice, the apothem shows us the perpendicular height. So area equals 1/2 base, which in this case is 10, and we need to find the height. So as we look in to find the height, what we have is this angle 60. I'm going to use blue because that line is red. This angle 60, we can split that into 30, 90, 60, 90 triangle. If this whole side is 10, then that means that here should be 5. Okay? And what we want to find now is our height in a 30, 60, 90 triangle. This would be 5 radical 3. So we found our height to be 5 radical 3. And so the area of one triangle would be 5 times 5 radical 3, 25 radical 3. That's the area of one triangle, centimeters squared. But there are 6 of them. So we multiply that by 6 to find the area of the whole figure, and that gives us 150 radical 3 centimeters squared. So we kind of talked about that. We'll walk through the process. Notice from the previous problem how many congruent triangles there were. There were 6 in a hexagon. If we find the area of one of those triangles, we multiply by the number of triangles to find the area of the polygon. But isn't there an easier way? Okay, and there kind of is. This is how we get to it. Area of a triangle is 1/2 base times height times 6. But what we're going to do is we're going to recombine this multiplication in a different way. Okay, we're going to do, instead of talking about it as base, we're going to think about it as a side. Okay, so area equals 1/2, and we're going to put 6 in sides together because there's 6 sides, times height. But the 6x represents the perimeter of the polygon, right? When we add all 6 sides together. Okay, so therefore, we can find the area of a regular polygon by taking 1/2. Remember that when we looked at the height here, we really didn't say, oh, the height. When we're talking about a hexagon and a regular hexagon, we call this the apothem, right? We use that apothem as a height. And so we will look at our formula as 1/2, not 6x, but the perimeter times the apothem. A lot of times you'll see it is written as A equals 1/2 A times P. Notice the capital A stands for area, the lowercase a stands for apothem. And you guys know I like typically writing in all caps, but making sure that you keep that organized is important here. All right, so here, asking us to find the area of each regular polygon, leave our answers in simplest radical form. So what we're going to do to help ourselves out here in this problem, we're going to draw the center. Okay, we have our radii. I'm just going to draw a couple here. And then we'll have our apothem, goes from the center perpendicular to a side. You can do this anywhere, just choosing to do this here. All right, so as we look at our central angles, right, 360, 3 sides divided by 3, 120. Okay, this apothem splits that central angle, and so we have a 60 here, 30 here, 30, 60, 90 triangle. In our 30, 60, 90 triangle, remember this whole side is 20, because that's what they told us. But for our triangle, as we're trying to find the apothem, because we need that, this whole triangle, or this whole thing was 20, but on this measurement here, in our 30, 60, 90 triangle, it's 10. Okay, and so as we try to find our height, we're going to remember our ratios that across in a 30, 60, 90 triangle, across from 30 is x, our hypotenuse is 2x, and then our across from 60 is x radical 3. Okay, so in order to find our apothem, we need to find out what x is, and so we'll do that by saying if x radical 3 equals 10, then x equals, we have to rationalize our denominator here, and we get x equals 10 radical 3 over 3, which isn't pretty, I'll admit, but that's all we need. So in this problem, we find that our apothem is 10 radical 3 over 3. We should now have all the information we need in order to find the area of this triangle. Area equals 1/2 the apothem, which we just found to be 10 radical 3 over 3, times our perimeter, which is 20, 40, 60. All right. So as we go through and multiply it, I'm going to do 1/2 times 60, which is 30, times 10 radical 3 over 3. All right, and that gives me 100 radical 3 meters squared. Okay, here we're given a square or regular quadrilateral, right? It has to be a square. And they tell us that our radius is 16 centimeters. I want to draw this in. Try to make a straight line. Okay, anyway, so our radius is 16. In our square, we have 4 central angles. Okay, and so they'd all be 90 degrees, but our apothem here, I should draw this a little bit different just so you can see. Our apothem would split that 90-degree angle there. And so we have a 45, 45, 90 triangle here. 45, 45, 90. What we need, remember, to find the area of a regular polygon, 1/2 the apothem times the perimeter. We need to find both the apothem and a side length because we don't know anything yet outside the radius, which isn't in our formula. But since we have this special right triangle, 45, 45, 90 triangle, we can use our ratios and know that the hypotenuse is x radical 2, the other 2 sides are x and x. So we have an equation that we can set up. If x radical 2 equals 16, then x equals, x equals 16 over radical 2, rationalize the denominator, 16 radical 2 over 2, which is 8 radical 2. So x is 8 radical 2. And that is our apothem, right? 8 radical 2. Okay, you'll also notice that since it's a 45, 45, 90 triangle, that means this side of the triangle is 8 radical 2. And that means that this side of the triangle is 8 radical 2. So an entire side of our quadrilateral is 16 radical 2, 8 plus 8. Okay, so as we're finding the perimeter, we have 4 times 16 radical 2. And that gives us 64 radical 2. That's our perimeter. We already found that our apothem was 8 radical 2. And so we can plug that into our formula. Area equals 1/2 the apothem times the perimeter. And then we multiply. Okay, so as we go through, 4 radical 2, 1/2 times 8 times 64 radical 2. And that gives us 256 times 2. That gives us 256 times 2 is 512 centimeters squared. Hey, you might be like, hey, this is a square. Like once we found this side, why don't we just do base times height? Well, we could have, I think, got the same thing. 16 times 16 is 256 times 2 is 512. Yeah, it would have been the same thing. All right, last one here. Excuse me. We are given a 1, 2, 3, 6-sided hexagon. It's a hexagon. Okay, and we have our apothem given to us at the beginning of this problem. So as we look at it then, zoom in just a little bit so I can write on here legibly. Okay. So 6 central angles, 360 divided by 6 should give us 60. Remember the apothem splits that. So this is a 30, 60, 90 triangle. And that's nice, very nice, because our apothem is across from 30 or the 60-degree angle, and it's 10 radical 3. We remember our ratios in the 30, 60, 90 triangle to be across from 30 is x, across from 60 is x radical 3, and our hypotenuse being 2x. And so since x radical 3 equals 10 radical 3, that must mean that x is 10. Okay, so we have x is 10. And so we have this is 10. That must mean that this is 10. That must mean that our side is 20. So our perimeter is the length of one side times how many sides there are 120. Our apothem was given to us at the beginning of the problem as 10 radical 3. And so we can find our area by doing 1/2 the apothem, 10 radical 3, times our perimeter, which is 120. 5 times radical, 1/2 times 10 is 5, sorry, 5 radical 3, times 120. And so we have 600 radical 3. Did they give us units? They did. So I'm just going to say units squared. All right. So that's area of a regular polygon using special right triangles. See ya.